All right, so this is our robot, and then we're here to talk about the design and building process. So when we started out, we decided that we wanted the robot to be able to intake from the front and shoot from the front. And basically, the purpose of that is so that if we have a ring roll if we have a ring like roll in front of the robots, we don't have to turn the robot around to intake. We can just intake and then not have to waste time turning it around. And so the design basically goes, we have these rubber wheels in the front. That would be the main intake of the ring. And then it would go up to a ramp, a slanted ramp at around 45 degrees. It would go up and then it would go up to a curved ramp in the back. If you can show that camera. That has a sheet of flexible acrylic, and then it comes up to a conveyor. Now, to move the ring vertically, we use surgical tubing tied around axles that are powered by motors, and then at last, it comes up here into a conveyor that feeds it to the throw wheel, in which one is here and then one is stationary. And the conveyor is made of duct tape, and it's also powered by another X motor. And speaking of motors, for all of our above drivetrain equipment, we used HD hex, Rev HD hex motors. They're all planetary, which means that we can gear them to certain ratios depending on our needs. Like for example, the intake here has around 1 to 4 or 1 to 5 ratios. It has a little bit more torque, and then here the conveyor also is a 5 to 1 because the torque issue.
Yeah.
And
so
then,
in the first competition we had, our robot, the motors kept like heating up because we had just this motor running 3 to 4 axles, and it was just too much for the motor. So the battery was dying, and the motor was getting very, very hot. So that's why we spread it out over 2 motors rather than just 1.
yeah, and speaking of those, they are chained. Each axle is chained together. There are 2 axles in the front that's chained together by 1 motor, and then in the back, here, there's another motor inside this beam that actually also powers 2 axles. The chain is less, you can't really see it that well, it's kind of hidden, but it's there. So, as for the throw wheel, we actually didn't have any gear ratios for this because we needed the speed instead of the torque. So, there's that. And then, as you can see, some of these parts are also kind of custom cut with our laser cutter. These are basically just 1/4-inch acrylic, and it's kind of interesting because a lot of, like 2/3 of the robot is basically built inside SolidWorks, and I was a big part of doing that, and that basically ensures that we can fit everything together correctly, and it also ensures that we can make custom parts very accurately because it's all assembled to scale inside a 3D program. And then, the other part of custom parts, Connor will talk about.
Yeah, so a lot of our parts, like you said, a laser cutter, we have a laser cutter. It's probably the most used piece of machinery we have in our shop. We also have a 3D printer, which was custom built for our team. And like you see this mount right here, it's a great thing for the battery. It was 3D printed and designed by us, and it's not on the robot now because it had to be fixed. But the phone mount for our phone that connects to the controllers, that was also 3D printed and custom made just for the bot. So those things, like in the acrylic, we all make it in-house. So that's, I think, what makes our robot special too.